Hello everyone, welcome back. This week we're going to start to build a little bit more of a more elaborate project in the form of a small game. And the idea is for us to kind of tie together all the concepts that we've covered so far in the first 8 weeks of the course. So um, it's going to be a little bit longer this week in terms of video content, but think of it as covering basically like 2 weeks worth of materials. So you can go through it at your own time. And the ideas we're going to cover in this game tutorial are going to help you develop your final projects. And a lot of the concepts we're going to be introducing are going to be helpful for you to create your games, even though your games are not actually going to be the same as the one we're going to be walking through in this tutorial. Okay. So let's talk about what we're going to be doing first. So as you know, our project for the course is going to be, our example game is going to be this project that I developed called Zombie Apocalypse. Okay? And this is what the game looks like. You can choose a character. This is the finished thing, and we're going to break it down into incremental steps. So you can select a character, and then once you do, the goal of the game is to stay alive as long as possible, as one does in the zombie apocalypse. There's a timer on the top left corner, that's our score, and the higher the timer, obviously the higher the score. In the beginning, it's quite straightforward, but as more and more zombies come in, they will eventually catch you. And there's some basic collision detection happening using circles. We're going to check if the player gets eaten by a zombie, and if it does, then we are game over, and we can try again and try to beat our high score. So that's the basic gist of the game. And there's a few other elements in there. Obviously, there's some music playing. There's the animation of the characters, and fonts and so forth. So we're going to develop this entire project over the course of a few videos. Okay, so before we get started, it's always helpful to have a little bit of a plan before you embark into a bigger project when you're programming. For small kind of sketchbook type ideas, it's okay to just dive in and start writing code. But anything bigger, I think it helps to do a little bit of planning up front. So for example, this could be like an outline for the game we're about to develop, right? What we're trying to do here is kind of map out what things our programs are going to have to do. We don't have to go into great detail, but we do this from the perspective of kind of writing what we call pseudocode, right? So this is going a little bit beyond just describing the game in English, and this is really thinking about the flow of the program and trying to do our best to map this out ahead of time, and then we can figure out how to implement it. So for this game I just showed you, for example, this could be a good outline, right? We're going to have some kind of intro in the beginning where we tell the program to wait for the player to select the character. Then we start the game, okay? And this is saying the character is selected by clicking. Then we move on to the game portion. And what happens when we're playing the game? Well, the program has to do these things. It has to draw and animate all the game objects. It has to constantly check if a zombie ever overlaps with the player. And if it does, then it's game over. So we're using here, things like if, right? This kind of language hints at the types of code structures we're going to have to use to actually implement this in our program. Over time, we're going to add more zombies, and we're also going to constantly increase a score. Okay? And then once the game is over, what the program has to do is show the player the final score, right? And then wait for a click, and then restart the game. So a basic outline, but already just by taking the time to map this out, we are kind of hinting at, things like if statements over here, right? What kinds of steps our program is going to have to take to eventually carry out this plan, this project. So in terms of the videos this week, here's how we're going to break down the different topics. In this first video, we're going to be talking about animation. So we're going to start at the beginning, and we're simply going to try to solve the problem of how do we get an animated character following our mouse cursor. Once we sort this out in the second video, we're going to build on this, and we're going to create our basic game objects. We're going to write some classes to represent the player object, even though we're just going to have one player in this game. And we're also going to write a class, or remember, a template to represent the zombie objects in the game. And we're going to develop those using object-oriented programming techniques. Once we've done this in the third video, we're going to start to talk about our core game mechanics, right? So how is this game going to work? Well, the main concept behind this game is collision detection, right? We need to avoid the enemies, and we need our program to be able to know when the player overlaps with one of the zombies. So we're going to talk about implementing collision in the third video. In the fourth video, we're going to talk about this concept of game states. The idea of states is an interesting one because so far all the programs we've built in this course only had one state, right? We could go from setup into draw, but they were all short sketches that only ever did the one thing that we programmed into them. In the case of the game, we need a little bit more structure in order to be able to go through different states. In our case, that would be the intro, right? Moving into the game mode, moving into the game over state. So we'll need to add a little bit of code scaffolding into our program to allow us to flow between these different states. So that's going to be the fourth video. And then in the final video this week, we're going to put some finishing touches on the game. That's going to be adding the score that increases over time. We'll throw in the sound, and we'll talk about how we might increase the difficulty by basically getting enemies to come in over time, and also maybe tweaking their behavior so they're a little bit more predictable and move in more interesting ways. All right, so let's dive into it. In this first video, we're going to focus on the animation. So I already have a sketch here that basically like a basic template. We just have our setup, window resized, and draw. And the first thing I'm going to do is bring in my asset files into my sketch. Okay? So I have those in a folder over here. These are going to be available for you to download on D2L, and just if you want to follow along with this tutorial. So my assets for the games are basically, I have these image sequences. These are the animation frames for my player character and my two different player characters. And in this first video, we'll just focus on one sequence. And in the finishing touches, we're going to talk about introducing player select, right, having different skin options. I have another sequence for the zombie animation. And I've numbered these in a strategic way. They all have numbers, right, that are going to represent their order in the animation sequence. So I have frame 0 will be the first one here, and frame 8 will be the last one. I have a little MP3 file, and I have a font file. And I'll put references to where these assets come from in the video description. We did make those, but they're all Creative Commons licenses or were made by somebody who gave me permission to use them. Okay, so to add assets to our sketch, we're going to go to Upload File over here, and we are going to drag and drop all the files that we need over here. Just be mindful that you have a 250 megabyte overall limit with the P5JS editor, so think about your file sizes and make the files smaller where you can. Okay, just don't make your files excessively large for no reason if you can avoid it. So I think these have all uploaded correctly, so I'm going to close this tab here. I can see all my assets over there, and we're just going to dump them all in the same folder here as our sketch, index, and so forth, just to keep things simple. Okay, so let's talk about building our animation. So the concept behind this animation is going to be quite straightforward. Okay, here's a slide to illustrate what we're going to do. So to represent an animation in code, of course we could have used an animated GIF if we wanted to, but this is, again, the point of this tutorial is to recap a lot of the ideas we talked about, so we're going to do it using an image sequence. So we're going to create basically an array of P5 image objects that is going to hold all of our images in our sequence. And this is what this array is going to look like if you visualize it. You can imagine at index 0, we're going to have the first frame of the animation, and then as we increase the index into the array, we're going to be moving down to other frames in the animation. Right? We're going to be moving through our sequence, and our job is going to be to loop through this array over time, so that in different frames we draw a different, in different frames of our program, we draw a different frame of the animation. And the way we're going to do this is we're going to use a variable, right, to animate the index. So if we store the index of the current frame inside a variable, we'll be able to increase that variable over time and choose a different frame as time goes on. So let's see what that would look like in our code. refresh here, see what happened. Do I still have my files? Okay, perfect. All right, I'm going to get rid of this one. So the first step is we're going to declare an array that's going to store our animation sequence. Okay, let's call this array animation images. And in our preload function, remember preload is where whenever we load files like assets, and we want to make sure these have been fully loaded before we get into setup and then our program carries on. We have this special function we can implement called preload that's going to guarantee any files we load in there are going to be fully loaded by the time setup comes around. Okay? So in preload, we are going to load our animation frames. Okay? So we have, in this case, we're going to start with the M player sequence. Okay? So we have 9 images in that sequence, starting from number 0 all the way up to number 8. Okay? So that means that the first image needs to go at index 0 in my array, right? So I would do load image mplayer-0.png. Okay. So that would be loading my first image, and then in draw, we might just make sure this is working by saying image animation image bracket 0, and let's draw it at mouse x, mouse y. Hit play. Oh, mplayer is a lowercase p. Always be careful. Always be mindful of the case of your file names. Okay, and animation images here as an S. There we go. Okay, so our first frame has been loaded correctly. So we have an array here. We have preload loading our image, and then we have our image function drawing the image at index 0. And we only have one image in the array currently, but it's always a good idea to run your code frequently, especially as you, obviously this is a short program, but as we start to build complexity into this, we're going to try to make sure we run our code frequently so that we don't get too far ahead of ourselves and don't know how to find our way back if something doesn't work. Okay. So the first thing I'm noticing here is obviously image mode, right? The default is the top left corner. So we're going to quickly change that in setup, image mode center, just so that the character is going to be centered on my mouse cursor. That's a little better. And now let's talk about loading the other frames in the sequence. So here we're loading frame 0 at index 0, right? And of course, we could do it that way, right? We could go and copy and paste, and that would load the second frame at index 1, right? So forth. But obviously, this is not practical, right? We have 9 frames to do, and there could be more in your sequence. So this is a great job for a for loop. So instead of doing this by hand like this, we are going to take this line, repeat it a number of times, and then use a counter to walk us through index 0 to 8. Okay? So here we're going to say smaller than 9. Okay. And in fact, let's define a variable that's going to help us know how many frames we have. Okay, so that's going to make it a little bit clearer. We're going to say, let's define a variable. I'm going to call it num frames here. This is the number of frames we have. And I'm doing this with a variable kind of with the optic that eventually we're going to need to make this a little bit more general because we're going to have to load an animation sequence for the player, but also for the zombies. Okay? So this for loop is going to repeat this line based on the number of frames we defined. And remember, I have 9 frames, right, starting from 0. And at each iteration of the loop, we can use our index, our variable I, right, and as an index into our array. So this is going to go into a different position every time. And then on the right side, what we need to do is we need to get the 0 to increase as the loop repeats. And the way we can do that in JavaScript is we can do it as such. So we're gonna isolate the 0 here by using the plus sign. So we're going to basically think of it as taking smaller bits of string and kind of gluing them together. So I'm going to take mplayer dash as a string, and then we're going to add to that the number 0. And then at the end, we're going to glue the extension .png. So by writing it this way, right, this allows us to have a number in the middle here with a string on the left and a string on the right. And the plus sign in this context just glues these little bits together back into one string. And then having done this, we can replace the 0, which is now a number, we can replace it with our variable, with the counter. So that's going to go and load all the 9 images that we have into this array called animation images. And we can test that real quick. Let's bring up a different frame. Let's change the index here, right? So now we have a guy kind of halfway through the motion animation. All right. So we have our array full of images. The next thing that we need, right? We need to animate the index over time. So we need to get this index as we draw our character. We need that number to constantly go up and then go back to 0, kind of in a loop forever, to create our animation cycle. So the way that we're going to do this is we're going to replace this fixed number here. That's just the number, whatever, 0, 4. This needs to become a variable, right? Because variables are how we get things to change over time in our program. So let's create animation index as a variable. I'm just making these names up here. We're going to start from 0. This is now going to become animation index. And now we have something we can increase over time and we can manipulate. So it doesn't have to be fixed. All right. So what needs to happen with the animation index? Well, it needs to go up, right? After we draw a frame, it needs to go up by 1. Okay? And if we ever exceed the number of frames that we have, so we can either refer to our numFrames variable, or we can just simply look at the animation images array and look at its length property. That will always tell us exactly how many images we have, right? So if animation images, if animation index, right, ever reaches the number of, like, the length, right? If we have 9 frames, if animation index reaches 9, we know that it's time to go back to the beginning. Okay, so we can write it this way. So this is going to ensure that we loop around, essentially. Okay? All right. So now we have our animation sequence running. Obviously, it's going really, really fast. We're going to talk about that in a second. And that's because, well, let's talk about that right now, right? So we're now cycling through our animation sequence, and that's because our frame rate is usually by default, right? P5.js tries to draw, I believe, is 60 frames per second if it's able to, right? That's what it's striving for. So 60 times per second, we are increasing our animation counter, and that results in a really, hyper looking dude. And, we could try to slow it down in setup if we went, okay, we're going to slow down the frame rate, for example, to 15 instead of 60. That's going to slow down our animation, but the problem with that is it's going to slow everything down in our game. Okay, those of you who are into playing games in general, you're probably familiar with the concept of frame rates, or FPS, frames per second. Usually want this number to be as high as possible in order to get a smooth experience, right? This is, if you think about video, right, usually that's 30 frames per second in order to get the illusion that things are not choppy, things are moving. Film is 24 frames per second, so you need to strive for those higher numbers. Anything less than that is going to look really it's going to be very unsatisfying to interact with. So we need a way to slow this down without having to mess with the frame rate. There are many different ways to approach this. In real actual games, usually this is based on time, right? So actual system time, and trying to figure out how many milliseconds have elapsed since the last frame and base the animation according to this. We're not going to be that sophisticated in this example. We're going to take a very simple approach, which is to say, like, if this is the frame rate I want, about 15, right? This is looking okay to me. And I know my program is drawing at 60 frames per second. What we're going to do is we're going to only increment this animation index, right, every 4th frame. So we don't want to increase it all the time. Rather, we're going to wait a little bit before we increment our animation index. And that's going to allow us to keep our original frame rate quick, right? But once in a while, go to the next frame so that the movement is smooth, but the animation is a little bit slower. Okay? So the way that we can do this is we can use there's a few different ways, but the laziest way we can do this is we're going to rely on this frame count variable. Frame count is a global variable that we have access to. Okay? And it's simply a counter. So it's just a number that starts at 0 when we hit play, and then it just goes up by 1 every time we draw a frame. Okay? So we're going to look at frame count, and we're going to use this modulo operator. Okay, so modulo we've looked at before, I believe, but we haven't. If we haven't, I'll explain it again. Modulo is the percentage sign, and it's the remainder of a division. Okay? So if you divide a number by, let's say, 4, okay, and the remainder of that division is 0, okay, that means frame count is a multiple of 4. Okay? So following me? So modulo, the percentage sign, gives us the remainder of a division. Okay? So in practice, what that allows us to do is take a number that increases to infinity, right? And then have something occur every time we hit a certain milestone. In this case, a multiple of 4. And we know this is a multiple of 4 because the remainder, if we divide that number by 4, is going to be 0. So that if statement is going to trigger on frame count equals 0, right? It's going to trigger again on frame count equals 4 and 8 and 12 and so forth. So every multiple of 4, the remainder, if we divide the number of frame count by 4, is going to be 0. So in practice, that allows us to do something every 4th frame, right? This is how you can think of it. If we did modulo 2, we would do something every other frame, right? Whenever frame count is a even number, we would increase the animation index. So this allows us kind of crudely to set the animation speed, right? In other words, we only increment the index once in a while, in this case, every 4th frame. And the modulo is a quick way to get to that result. Another longer way to do it would be to create our own counter, right? The way we have animation index, and then when that counter reaches 4, we could reset it back to 0. That would work too. This is just a little bit of a shortcut for the lazy. So we can refer to frame count kind of as think of it as this kind of global timer that's happening, and we divide it, right? So that the effect is that it's going to constantly wrap around. Essentially, it doesn't matter that the number keeps going up. We're always dividing it by 4 and checking if we hit a perfect multiple of 4 when the result is 0. Okay? So this is how we can slow down our animation. All right. And then finally, the last little thing we're going to do for this video before we move on to kind of creating our game objects is we're going to add a little bit of refinement to this, where as I move my mouse cursor, we're going to adjust how we're drawing the player so that it's facing in the correct direction that the player is walking towards. So what I mean by this, if you notice, I move my cursor to the right, everything's fine. If I move my cursor to the left, now my player is moonwalking, right? It's walking backwards. Maybe for your game that works fine, but for my game, I'd like this player to start looking the other way when my cursor is moving to the left. Okay? So how are we going to do this? Well, there's an easy way we can do that using transformations. We don't really need a brand new animation sequence facing left. We can simply reuse our facing right animation and just mirror it, right? If we just flip it around the y-axis, we can reuse those frames. We just have to draw them mirrored. Okay? And the way we do this is we can use a negative scale. We covered this in the video on transformations, right? If we bring our origin to the center of our character at the 0, 0 point, if we apply a negative scale on the x-axis, it's going to create a mirror effect, and it's going to draw our character in reverse. So let's see what that would look like. So first we're going to bring the origin to the center of the character. So that means we're going to translate, right? Mouse X, mouse Y, and then we're going to draw the character at 0, 0. Okay, so this is an important step. It makes sure that the 0, 0 point, instead of being up here, is now in the center of the thing I'm drawing. And that in turn means that the, both rotate and scale, right, always work around wherever that 0, 0 point is. If I left the origin up here, if I did a negative scale, my character would basically be drawn over here where my code is, and that's not what I want. So with scale, if I do a scale of 1, right, it doesn't change anything. Scale of 1, remember, just it's the same. Scale of 2 makes everything twice as big, okay? And a scale of -1 keeps the size, but it inverts, right? It inverts along both the x and the y axis. Now, in this case, I want to be facing left. That's great, but I don't want to be walking on the ceiling. So we're only going to scale by -1 along the x, and we're going to leave the y-axis alone by leaving it as a 1. Okay, so we can decide different amount of scaling across different axes. So now this is great because I have a way of drawing the same sequence, just flipped over, and now I have a character facing left. So what's left for me to do now is figuring out, okay, well, when do I want this to happen? Obviously not all the time, right? When my character is moving to the right, I want to see one flip, right, one scale, and when the character is moving to the left, I want to have another scale. So what we need to do is take this number one, this -1 here, and turn it into a variable, right? That's the first step, because whenever you have something that needs to change in your program, odds are replacing that thing with a variable is a very good starting point. Okay? So let's start with that. -1 here, I need this number to sometimes be -1, sometimes be 1. So we're going to make it into a variable. Let's call that variable flip. Okay, and flip, I'm going to think of it as, that's the orientation of my character. I can flip it. So if I set flip to 1, right? So I replace -1 here with flip. If I set it to 1, I'm facing right. If I set it to -1, I'm facing left. Okay? So now we have something we can change in the code to change the direction our player is facing. All we're missing is some code that will actually do the change. Okay? So we're going to need some kind of a question here that's going to keep an eye on what my mouse is doing. And it's going to say, if the mouse cursor is moving right, set flip to 1, and if the mouse cursor is moving left, set flip to -1. Okay? So this kind of implies that we're going to need some kind of an if statement. Okay? So how do we know if the mouse cursor is moving to the right? Well, one easy way to determine this, right, is and I think I have a. Oh, no, I don't have a slide about that. It's okay. One easy thing to determine this is we have access to two variables in P5 that relate to the mouse cursor. We have two sets of variables. We have mouse x, mouse y. This is the current position of the mouse cursor. And we also have p mouse x and p mouse y. These represent where the mouse cursor was one frame in the past, right? So in the previous frame, where the mouse cursor used to be, if it moved at all, right, it'll be different. So we have these two variables we can compare to see what's happened to our cursor. So for instance, here we're only interested in the x-axis to determine which direction we should be facing. So if we were to compare mouse x, this is where we are right now. Okay, if that number is bigger than p mouse x, right, then it means we're moving to the right. Because if p mouse x is less than where we are now, then we must be moving to the right. So if that number is bigger than mouse x greater than p mouse x, then we're facing right. Okay, and then the opposite of that is if mouse x is less than p mouse x. In other words, if our previous position, right, if our current position is less than our previous position, then surely we're going that way. So we're set to flip to -1. It means we're facing left. Okay, let's see what that looks like. Perfect. And then if we don't go anywhere, right? If we don't move, we just don't change the direction, which is great because these two statements, right, don't do anything if mouse x is exactly equal to p mouse x, which means if we're just standing still, we're going to essentially remember the last direction that we were facing and just leave it at that, which is the perfect behavior that we need for this little animation. And we get that because we're using greater than and smaller than. So the case when the two are equal, we simply don't do anything. Okay, we just leave flip alone and it's going to stay the same until there's a change. So now we have our character facing the correct way as I move my mouse cursor. Awesome. Okay. So that's how we would do animations, right, in P5. So just to recap briefly, right, we created an array that stores our image sequence. In preload, we use the for loop to load every image in the sequence, and that will work regardless of how long that sequence is. That's the beauty of for loops, right? We don't have to do this one image at a time. We let the computer do the work for us. And here we use the index, both to set the index in the animation images, but also to set the file name. Okay, so this is really important to have files that are numbered, right, in the correct sequence. This makes our life easy. We just have to insert then the variable I, right, at a strategic place in the file name, and it will just magically work. And then once we have our animation images array, we increase an animation index variable every 4th frame, right? And when that animation index reaches the number of frames that we have, we know it's time to go back to the beginning, right? Go back to the beginning of the sequence, and we're going to just do this forever. And then finally, we added a nice little touch here where we scale our animation to get a left-facing character and a right-facing character, depending on what the mouse cursor is doing. So we're going to leave it at that for this video. In the next video, we're going to talk about, now that we have kind of prototyped this animation idea, we're going to build a more elaborate class. We're going to turn this player character into an object, and then we're going to use that as a starting point to create also a zombie object, so that by the time we're done, we have a player object and we also have a zombie object. These are going to be the building blocks of our game. So I'll see you in the next video.